Okay, the first mating shortcut is something called quick mates, and it's akin to what we do in a sketch, where we might have two circles, and we want to make them concentric, so we're going to add a relation to do that, and we have the option to use a quote form, where we're going to add relation with the add relation tool, fill out the form, make them concentric. But we could also control select them both circles, and then use that little pop-up tool to add the relation. Well, the same kind of thing happens now in SOLIDWORKS with quick mates. Quick mates were introduced in SOLIDWORKS 2015, and they added some things to them as far as capabilities in 2016. Basically, the way quick mates works is you hold your control key down, and you select entities from two components that you'd like to mate. The key is that I'm holding my control key down as I select the faces in this case, and then when I'm ready, I let go of the control key, and based on my selection set, I have a pop-up toolbar with a ribbon that shows available mates for what I had selected. So I can choose concentric and get that mate to happen. Now I want you to notice that what we don't have with quick mates, for example, is changing mate alignment. So I want to make sure that this part is oriented with the correct way, quote, into my housing before I do the quick mate. I mean, I can always, after the fact, change it. Find the mate by picking on the part and using breadcrumbs either from over here, right-click and flip alignment or edit, or click here, hit the D key on the keyboard to bring the breadcrumbs right next to my cursor and, again, get to the mate from here, right-click, edit. And certainly I could find the mate in the mate group and all that as well. So quick mates, once again, are going to be achieved by holding down your control key, selecting elements and parts like these two here and here. Let go of the control key to bring up the pop-up menu or pop-up toolbar, as well as available mates. Choose the mate you want. Now if I choose a distance mate here instead of coincident, I will get a box for the mate distance. It will show me what the number is as far as how far apart those two faces are currently. Now here I do have some modification abilities. I can hit 40, hit the tab key to accept that, 30, tab key to accept it, use the spin box arrows up and down, and also I can flip the dimension side to measure inside or out. But again, notice there is no option to change alignment. There is no option to change alignment in this case. So go ahead and accept that. And that would be quick mates for standard mates. So they're talking concentric, coincident, distance, parallel, things like that. Now in 2016, SOLIDWORKS added the capability to get some other types of mates through quick mates. And that includes something like the with mate. So I'm going to delete the mates I have here, at least the distance mate. Accept that. And then I'll do a quick mate using the distance mate. So a distance mate is a mate that, I'm sorry, not a distance mate, a with mate. In SOLIDWORKS 2016, we added the capability to do advanced mates, including a with mate, using the quick mates functionality. So a with mate would be picking, say, two faces on part A and two faces on part B, and then getting the parts centered to each other. And in this particular case, I'm going to select, for example, the two ends of the shaft, my control key held down, and then these two planar faces on the housing, again, control key held down the whole way until I let go of the control key, and you'll see the with mate option appears with those selected elements. Again, we don't have the full control of the mate options. We don't have, for example, a way to say don't be centered, but to be a distance or percentage along the way. I could certainly change that after the fact. Pick this part, bring up the breadcrumbs, edit the with mate, and then change my with mate from center to free or other elements like that. But that's what the quick mate does, is really it's, hey, the parts are in the correct orientation, and I want the most, I'll say, quick or standard option for a quick mate. I should also mention, I'll delete the with mate again, that when you're selecting, I did the initial selections here to show picking 2 faces on the red shaft, picking 2 faces after that on the gray housing, but it doesn't have to be in that kind of an order for this to work. I'm going to delete the with mate here and redo it. So it would be more convenient if, if I'm turned this way, to just pick the 2 faces on this side, one for the shaft, one for the housing, spin around, hold my control key, and pick these 2 faces here. So the order's not going to matter. When I let go of the control key, it susses out you have 2 faces on one part, 2 faces on the other. We can do a with mate with that, and there is your result. So quick mates are a simple way to get mates very quickly by control selecting elements from one part to another. Just hold the control key down until you have your selection set where you want. Let go of the control key, and then choose the mate type available based on what you selected. And if you want some more information on specifically what kinds of mates are available through quick mates, I recommend you go to the help, look up quick mates, and here you see in the help more information on quick mates, including some of the different mate types that are available to you. Another way to create mates using shortcuts is by creating mates as we drag and drop. This is something that is called Smart Mate. So the way Smart Mate works, well, already we know we can drag and drop components in the assembly. I can take this shaft, which I've removed the mates from, and just drag it around in space, and it's going to be movement based on the degrees of freedom that that component has in our assembly space relative to our view plane, so what my view orientation is up and down from that sort of plane perspective. As I'm moving this around, if I hold down the Alt key on the keyboard, you'll notice that my display changes. The part I'm dragging becomes transparent, and next to my cursor is a symbol for mate, the paperclip symbol. What I'm going to do is move my pointer over entities in my assembly that could mate with the face I'm dragging with the Alt key held down. So if I just move the Alt and move it over here, let go, and that's it, I just moved it apart. But the magic happens is when I Alt drag and my pointer goes over a face that could mate with the face I'm dragging. So, for example, this face is a cylindrical face in the housing that could mate theoretically with the cylindrical face I'm dragging on the shaft. Or this face here, or what I'm looking for is this face here. And the symbols we see next to the cursor, I call them the barrels symbols, basically means you're smart mating between cylindrical faces. Again, the face I'm dragging with my pointer over the face I'm dragging to with the pointer. And the other thing about this is if you let go of the Alt key, but not the left mouse button, and then I hit the Tab key with the left mouse button still pushed down, the alignment for the mate changes, so aligned to anti-aligned in this particular case. As long as you don't let go of the left mouse button, you haven't finished, which means you can go, oh, well, let's snap it over here instead, or wait, let's go snap it over here, or to this, or, well, in my case, back to here, tab it. You want to make sure you get in the habit when you're doing the tab to let go of the Alt key. Because if you hold the Alt key down and then you hit Tab, Alt-Tab is a Microsoft Windows shortcut. That's going to change your current application. So you have your email and web browsers and what else up in the background. Alt-Tab would switch to those other, switch between the applications. So you don't want that. So just make sure you let go of the Alt key before you hit the Tab for the alignment flipping. And then when I'm done here, I can then let go of the mouse, and then a pop-up will appear confirming the default mate type for cylindrical faces, which would be the option I have, and just hit the green check, or I could choose something else, like I'll make those faces tangent instead of concentric or something else like that. I'm going to go ahead and accept this concentric mate. Note that lock rotation is an option here. So unlike quick mates, smart mates, we have a little bit more options with this because we can change the mate type as well as the settings. Go ahead and accept that, and we have our concentric mate. And to do another one, I'll hold my Alt key down as I drag this cylindrical, the end of the cylindrical face, so it's a planar face, to another planar face here. We get another symbol, these little planar face symbols. That means planar face to planar face. Let go of the left mouse button when I'm ready. Confirm coincident or choose something else like distance. And I'll have the option to change the distance, change the direction of the mate, distance mate, dimension, and set that to, let's say, 20. And I'll go ahead and accept that. And here I have my part mated using smart mates. Now, smart mates aren't any different kind of mate. It's just another way to get there. So instead of using the mate command or even the control selection methodology, I can get mates as I drag and drop. Now, there's a little bit more to the story than just that. In some situations, some special situations, you can actually get more than one mate at a time. What I'm going to do is insert a component, which will be this cover that will go to the front of this housing. And I drop it out here in space. And then I'll alt drag using a circular edge. Now, let me spin this thing around here and discuss this a little bit more. I'm going to use this edge for mating purposes. This edge is the meaning of two types of mathematical faces. A cylindrical face, meaning a planar face. If I hold my Alt key down and drag the part by that edge, when my pointer moves over something that could mate to that edge, for example, this top face here, I get a little symbol for planes, or the front face here. Because the circular edge is the boundary of a planar face, so it could mate to planes, but it can also snap to the holes, the circular edges, and then I get a little different symbol. The pin and hole symbol we're seeing here, or here, or here. I'm going to let go of the Alt key and hit the Tab key to flip alignment. And when I let go of this mouse button, left mouse button, I don't get a pop-up confirming a mate type. I get 2 for 1 in this case. So what SOLIDWORKS did is it took the cylindrical face that matched up to the edge I was dragging and mated that concentric to the cylindrical face that matched up to the edge I was dragging to. So I dragged this edge with the Alt key down to this edge here. Cylinders mate concentric, planar faces here, and then the end of the shaft made it coincident. And so this thing can spin, but other than that, I got the 2 mates. Now that's just to show you kind of how that works. Obviously, I don't want this thing really mated here, so I'm going to go ahead here and delete the mates. And do a smart mate. Really what I wanted was Alt drag this guy to this guy. Let go, and we have it. Now, if you look at the mate group, we actually got 3 mates this time. Concentric for the outside cylindrical faces, coincident for the outside planar faces based on the edges I was dragging from and to. But in between there, we have another mate, which is a concentric mate. Now, this is another special case. So we get 2 for 1 special case, circular edge to circular edge, in the situations we've been looking at. If the components involved in that circle edge to circle edge mate, the pin and hole type of mate, if those 2 components both have circular patterns of holes with the same center for the pattern definition and the same number of items, then SOLIDWORKS will add a third mate, which would be mate one hole in one of the parts to a hole in the other part to match up the patterns. Now, again, they have to have the same center spacing, the same number of items. I can't have 6 in one and 4 in the other. Wouldn't know how to match that up. The holes don't have to be the same size, though. As long as they have the same centers that match up, from one part to the other, so I can have one bigger for clearance, what have you. As long as they all match up to the center of the main mate, the cylindrical mates on these faces here and here, that all matches up, it'll pick it up for the third mate. Now, depending on how the part's flipping around, you may need to edit that, but in this case it flipped around exactly the way I want with the tab on the top. So holding your Alt key down allows you to create mates as you drag and drop. And then, again, depending on what you've got brought in, I'm using, right now I've done planar faces and circular edges. You can certainly do linear edges. You can certainly do vertices. I'll bring another part in just to quickly show a couple of examples of that. So I could, for example, Alt drag this edge to this edge here. So edge to edge mate, accepted. And so I have coincident between the two edges. Of course, I can still pivot and do this. Okay. You can also do vertex. So here's a point, vertex here. I can hold my Alt key down and drag that to another vertex like this one here to mate it like so. Although I probably wouldn't mate edge and vertex for this, just wanted to show you how that can work. Okay. So smart mates are a way to create mates while you drag and drop components within your assembly, holding down the Alt key. Smart mates can also be created when you drag and drop a part into the assembly in the first place from an open part window. I'm going to delete this yellow cover from my assembly and bring it in and do mates at the same time. So I'm going to hit R for recent documents and open up the cover with the lug in its own window. So here's the part window open. I'm going to tile that to the left, tile my assembly to the right. And then what I'll do here is I will bring the part in from the part window directly into my assembly window. And I'll do so by grabbing an edge that I want to mate with. Now there's no Alt key necessary here. My hand's up from that. Just drag and drop directly. I will get the smart mating. The pin and hole symbol is there. And here's the other cool part about this methodology. When you bring a part in from a part window into your assembly by geometry, you're doing smart mating without holding the Alt key. In this situation, the Tab key will do aligned or anti-aligned as we saw earlier. However, if you have the whole pattern matching scenario like we do here, the Tab key does something else. It changes the pattern matching. As I hit the Tab key a few times, you see that pattern match change evidenced by the tab on the cover changing around. So I do that, let go, and it's in there. Flip it around and repeat the process, same for the back side. And tab that up, accept it, and there you have it. Okay. To expand a little further on mating shortcuts, we could tell SOLIDWORKS that at least some of our parts have what I'll call a predefined mate or a mate preference. That is to say that when I bring the part into an assembly, treat it as if I had the part file open and was dragging and dropping by a specific face or edge for smart mating purposes. This way I don't have to have the part file open, but I can still take advantage of smart mating. This is something that has to be defined in the part itself, and it's a reference item. Go to Features, Reference dropdown, and I will define a simple mate reference. A mate reference, I'm just going to keep it the name default, and primary entity, what you want to mate with. Again, think what you drag and drop the part into with, or into the assembly with. I will pick this cylindrical face. I'll leave it to default, although I could narrow it down to just be concentric or something, and I'll leave it any alignment. And then I'll accept it. So it's very simple. Just, hey, what would you like to mate with on a regular basis for this component? What is a likely item? Typically, I bring the shaft into an assembly, it's going to be concentric to something with this face. So I have that basically captured now. And so I'm going to go ahead and save that and then close this part. And then when I bring it in any other way, for example, insert component, browse, offset shaft, when I move my cursor over something that could mate with my mate reference definition, cylindrical face there, or here, or of course what we really want is over here, I can get that in. And then the tab key would flip the alignment. I'll go ahead and accept this, like so, and I have my mate in there. So the concentric mate was created as I brought the part in. Just saves me that extra step of having to run the mate command or quick mate or alt drag. As I bring it in, I get a mate right away. Okay. And if you have situations where you can get the special case scenario like the round cover, flange situation, what have you, you can take advantage of that there too. So I'll go ahead and bring up my yellow cover. I will go to the reference drop down and add a mate reference here. Keep the default name, primary reference entity. I'll pick this edge. Again, any mate or alignment to keep it as flexible as possible. And I will save that. Close it. And then I'll bring that part in. And this time, just to be different, I'm going to hit R on the keyboard for recent documents and open the folder where that yellow cover lives. And then I will drag and drop this in directly from the open window or Windows file folder. I could also, of course, drop it in from the design library. So I'll take this guy and drag and drop him in. And again, it's like I'm dropping it by a face, or in this case, an edge. And the other cool thing is, since you're bringing it in from another source, it's not already in the assembly, the tab key does that. Aligned or anti-aligned normally, but again, in this case, it's doing the change of hole pattern matching. So I bring that in, flip it around, do it again, like so. Now, there's also more to mate references potentially. There's secondary and tertiary elements. There's naming the mate references, but that's going to go a little beyond what we're doing today for this, the mating shortcuts. Just doing a simple mate reference, leaving the name default, picking a simple element, and just that step right there can, again, save you some time. You bring the part in, it's going to want to mate with the element you predefine. And you don't have to do it. I could bring the shaft in, insert component, and bring it in again. And if I don't hover over something it could mate with, here or what have you, if I just drop it out in space, well, no mates are created. I could make this some other way if that's what I want to do for this situation. So you're not married to have to use the mate reference in all cases. It's just there and available for common scenarios for your common parts. Another mating shortcut is to use something called multiple mate mode, which is part of our standard mate command. I have just mocked up something really simple here. I have 2 copies of this shaft. They're both just fixed in space so that for now neither one's moving. I have 3 of those yellow covers that what I ostensibly want to do here is mate each of these 3 covers to, let's say, this face of this shaft. Now, I could run the mate tool and say, okay, this face and this face, concentric, accept the mate, and then repeat to make another one, this face and this face, accept it, this face and this face, accept it, and I've got all 3 of these yellow covers mated to this one face. But this was common to all 3 of the covers. So to get that done a little faster, I'm going to undo this, cancel out. I'll bring up the mate tool again. I'll hit this button here, this little paperclip with the lightning bolt. It's called multiple mate mode. And so when I accept that, I get a little different mate dialog box. The first box is a common reference. In this scenario, the cylindrical face of the first shaft. After that, I'm selecting things to mate with this. So I don't have to pick 1, 2, 1, 2, 1, 2. It's pick 1, 2, 3, 4. And I don't hit OK until I'm done with the mate. Each one of these components is now mated to the common reference. Less mouse clicks here. Also, I still have full control over what's going on in this set. So I could, for example, go back to the first item, the first mate, and say, for instance, let's reverse alignment. Or the second one, or the third one. And then once I'm finished, I can tell SOLIDWORKS that I'm done. Now, there is an option called the multi-mate folder. This remembers the last option that you use. In other words, if you have it turned on the last time you did the tool, it stays on. If it's off the last time you use the tool, it stays off. I'm going to turn it off for now and hit OK. And then finish the mate tool. And then we'll examine what we have. In our mate group, we have our concentric mates, 1, 2, and 3. They're top-level mates, as if I had done my initial example, which is control, pick 1, pick 2, pick 3, pick 4, pick 5, pick 6. They're top level, and they're editable and definable within each individual. Another option, though, that I had with the mate multi-mate mode is to create a multi-mate folder, which I'll activate again. So again, common reference, mate this to the common reference, this to the common reference, this to the common reference. I'll go ahead and accept it. And then we look at the mate group this time, there is a multi-mates icon for a sort of folder that contains these 3. Now I can still pick any one of these individually and flip alignment or edit or what have you. But the fact that they're grouped together in a multi-mate folder, that has one advantage. Besides the hierarchy as far as organizing it, the big advantage here is that if I want to change the common reference, I can do so after the fact. In other words, I can right-click on multi-mates, edit feature, and pick the first box and say we're not mated to the shaft on the first side, we're mated to the second shaft over here. And then these guys will all just adjust to that side. So if you keep them together in that multi-mate folder scenario, you always have the option to change the common reference, and then everything that was mated to the first common reference would go to the second or the new common reference. You can also right-click here and dissolve this and have them all be top level, at which point they're not grouped together and you can't just change the common reference in one fell swoop. So if you have multiple items that are mated to the same entity, try using the multi-mate option and potentially even keep them grouped in a multi-mate folder in case you want to change the common reference down the line. My last mating shortcut for today is a command called copy with mates. So in this scenario, I have a pin. I want another one of these pins, say, over here, and then also over here. Now I know I could hold my control key down and drag that pin to copy an instance into my assembly. And then I could control select these two to a quick mate concentric and then what have you, or I could right drag and spin this around and alt drag to do a smart mate, or maybe this edge to this edge alt drag. I mean, I have other options to make a copy of the component and then after that put in some mates. But one of my favorite little secret options is this thing called copy with mates. It's under the insert components dropdown because you are making a copy of a component. A new component will be created from an existing, as an instance, of course, not a new actual part number, but just another instance. Copy with mates starts out with, what are you copying? In this case, just one part, but it could be multiples. It's this pin here. I hit the arrow for next, and what you'll see is that the copy with mates has picked up the mates that the original component has. You can see the highlighting for the concentric mate, the orange face here. The coincident mate, the orange, the purple face here. And then all I'm doing here is I'm saying, well, let's make a copy of this part, the pin, by putting the concentric mate to a new location for the copy here, and the coincident mate to a new location, this face here. And then I can hit the right mouse button to advance, accept that and advance to another instance. Again, the first box is concentric, the second box is coincident. Right-click to accept it. First box is concentric. The second box is coincident. Right-click to accept it, and keep on going, but I'm going to be done with this for now. Okay? And so, as the command went along, it kept making copies of this guy and positioning them based on the mates from the original, transferring to the elements I selected in the new spots. Now, something else that you can use to kind of speed this along, that's why I have a bunch of holes in this part that I added, is repeat. So if I run the copy with mates command, and this is my parent instance, when I come to this box, I'm just going to say the coincident repeats. Because that way I don't have to keep picking this face for 1, 2, 3, 4 more instances. All I have to do is pick the face to be concentric to for each copy. So concentric, accept, concentric, right-click to accept, concentric to that face, right-click to accept. It just keeps on creating new instances with the repeating of coincident to the top face, just doing the concentrics. And again, you can then turn this off as you go and have to stop the command. And I can say, okay, we're going to go to the other side, and the concentric is going to be this face, coincident is going to be this face, and concentric and coincident as well. So that's the copy with mates function. The shortcut is that you're getting the copy of the part, but also getting the mates quickly done by not having to basically keep adding the same mate type over and over again. It's already defined. Just pick where you want the mate definition to go for the new component instance.